first question. So the first question was that a number has to be taken as input, and then we have to check whether the product of the first two digits and the last two digits are the same or are they not. If they're same, then you have to print that okay, the products are same. Else you have to print that they are not same. So has anyone tried? So I'm just assuming that there's an int n. Printf statement लिख के enter a number. I hope you guys can see the screen. फिर scanf लिख लेना और उसमें input ले लेना. I'm not writing this. I hope you can write it easily. Then see, we have to first find the last two digits of this number. So that can be done by making, see, the last digit 1 is equal to n mod 10. Then n is equal to n by 10. Okay. Then the second last digit, which is last digit 2, is equal to again n mod 10, because once we have done n by 10, so the last digit has been trimmed off and we have second last digit. So basically we have got last digit 1 and last digit 2. Now in this process, now we have to do reverse of the number. For that, basically we can't use n now because we have already trimmed n. So n has been distorted here. Okay. So what we do, we already save a copy of n. For example, p is equal to n. Now p has the same value as n. Now we'll reverse p. So while p not equals to 0, okay, sorry. While p not equals to 0, x is equal to p mod 10. Okay. Then r is equal to r into 10 plus x. Okay. P is equal to p by 10. So what this program will do is, it will store the reverse of our original number n, whose copy is in p. So using p, it will store the reverse of n in r, right? Every time we are taking out a digit and we are reversing it in r. I think this is the program that we have already discussed, how to reverse a number. So I hope this should not be an issue for anyone. Okay. And of course we trim it so it goes on, and we have the reverse in r, right? Now we do the same thing with r what we did with n, because now we find the last two digits of r, which will actually be the first two digits of n. So first digit 1 will be r mod 10, then r is equal to r by 10, and the second digit, sorry, will be again r mod 10. Now all we have to do is we have to check this. If LD1 into LD2 double equals to first digit 1 into first digit 2, then printf product same, else printf product different. That's all. Okay, so I hope it is clear. There can be different ways. I hope it is clear. You can have a look, and if anybody has a doubt in this question, please ask. Here we have taken out the last digit 1 and last digit 2. Then, and this is important. See, storing n in p, because if you just pay attention here, we are changing n. So you cannot use n to find the reverse of n. We have to use another value. Therefore, we have to have stored a copy of n in p, so that we can use that for finding the reverse number r. Is it clear to everyone? Then we are using the finding the reverse, and then we are using the reverse r. We are finding the first two digits, and then we just check the condition which we are required to check. And if they are same, then we print that product is same. Okay. See, the next question we had to do by method. So the question was basically that you have to take the input of how many shirts the customer wants, what is the cost of one shirt, and what is the discount on each shirt, and then you have to finally print the cost, I mean the bill for the customer. But you have to make a function for which does all this only if you give the function the values n, x, and d, or any variable for yourself. Okay, so let us first just start with the main function. Okay, so basically what I'm doing is int n x, what is else, y में डिस्काउंट शेयर कर लेते हैं, yeah, then printf statement enter n x y. Of course, if you are a shopkeeper, then you will prefer to write a more beautiful statement, but I'm not one, so I'm just managing with this one. Scanf percentage d percentage d. Now see, look, we have to be careful here because we are using int values. Okay, so we have to be a little careful here. And okay, sorry, not a, and n and x and y. Okay, now see, the final amount can be in decimals, so what I'm using is float amount is equal to, I will be making a function called my shop. I've not made it till now, but I know that I'll be making it, and to that function I'll pass the arguments n, x, and y, and that function will return to me the final amount, which I will print to the customer. Printf your bill percentage f. Now see, amount is float, so you must remember that the return data type of my shop will be float. Okay, now the main function gets over here. Now all that we have to do is we have to create a function called my shop, which will be accessed by the main function, because when the compiler reaches here it will look for a function called my shop, so we need to create that function. So the return data type of that function will be float, because we know that we are returning it in amount. Float my shop. What are the formal parameters? Int, I'm using capital N's here so that you don't get confused. They are different variables. Even if I use small n, still they are different variables. Now once we have got the inputs here, then we create a variable here called float amt. See, it's not that they are same. I can even write float amount here. So you need to remember this. Then I can maybe, okay. So in amount, I calculate, okay, let me create a variable SP, selling price. So selling price of one shirt. So what is the selling price of one shirt? X minus, sorry, I have to use capital X here because I have received the values in capital X. So basically it is X minus Y divided by 100.0. This should be remembered because Y we have taken as integer, and this into X. I hope this part is clear. So this is the selling price of one shirt. Now what is my amount? Amount is nothing but selling price into the total number of shirts, and then we return this amount variable, and then we close the my shop function. Just have a look from top. This is the main function which starts here. We take the input nxy, we send them by making them arguments for the my shop function. At this point the compiler goes here, these values are received in capital N, capital X, and capital Y. Okay, then our function my shop works on it, calculates the amount, which is a float value, and then returns the amount. Therefore, the data type, return data type, is float here. And this is received in the AMP variable in the main function, and which is printed. I hope it is clear. Guys, just take 10 seconds, 30 seconds to absorb it. If you think that you should first, you are mentally you are more comfortable making the my shop function first, then you make it first. Maybe I felt more comfortable making the main function first and then the my shop function. It's completely up to you. Now let's move forward to our next topic. We'll learn about the scope of variables. See, what is the meaning of scope? Scope basically means range. So मतलब एक वेरिएबल की कितनी औकात है, how much level it, which is the range in which it can exist, it can be accessed, it can be used, it can be manipulated, it can live. उसकी लाइफ का जो स्कोप है एक वेरिएबल का, उसको स्कोप ऑफ अ वेरिएबल कहते हैं. ओके, so the most basic way to understand this is that a variable exists only within the block it has been defined. Block, if you remember, this is a block within a curly bracket. So if you have defined a variable a here, declared a variable a here, so this variable a can be used only within this block. If you go out of this block, it cannot be used because it was created here, and it was created in this block, and it gets destroyed as soon as this block ends. Okay, so once the block terminates, its life is over. Based on this, scope variables can be of two types. These are some terms which you will read here many times: local variables and global variables. So the name only is very clear: local variable, which are present locally. I mean, if in a method or a function, if a variable has been created, so it can be used only within that function. For example, if you remember in the previous question, we created a variable SP, selling price. So that variable was created within the function myShop. This means that that variable can be accessed only in myShop. If you try to access that my variable SP in the main function, you can't access that. You will get an error. Okay, so it was a local variable. It was created inside a method and was accessible only in that method. Okay, and what is a global variable? A variable which is created or declared outside a method in a program, and therefore it can be accessed by multiple methods. It's called a global variable. So accessed by multiple methods. Okay, I'll just show you a picture on this which we have here. Yes, it's just the same thing that I told you. If it is inside a wave function, which has been declared inside a function or a block, it is a local variable. If it is declared out of the functions, for example, if I create, for example, this is my main function, right? And this is my shop function. Now, if I have created a variable here, int n, so this n can be used even in the main function and even in the myShop function. So this is a global variable for this program. Okay, I hope it is clear. And in a function parameter, so these are formal parameters. For example, in myShop here, if you remember, we had capital N, capital X, capital Y. So these were the formal parameters. I think I've told you about formal parameters before also. Okay, that's all about local. And okay, now we come to header files. This was where our programming started from. I mean, it is the first line. And preprocessor directives. See, what is a preprocessor directive and what is a header file? If you remember, this was the line which we write in the beginning of a program: include stdio.h. So we discussed a little bit about them, but we'll understand them better here. So this is a header file, and this is a preprocessor directive. See, preprocessor directive, basically what it does is it directs or instructs the C compiler to process the header file before starting compilation. So before the compilation of your program starts, even before that, this header file has to be included in the has to be loaded for the program. So this is directed to the C compiler by this hash include. So this is called the preprocessor directive. Okay, directives which have to be implemented before the processing starts. And these are the header files. As you already know, they contain a set of functions, library functions, standard functions, which you will be using in your program. Okay. For example, this is the standard input output header file. So it includes printf, it includes scanf, it includes gets, puts. We'll read about these functions in later part of the class. So it includes these functions which we might be using. So if you are using those functions, then you have to import this package. Let me just show you some common header files. Yeah, these are some common header files which we use in C. I'm sure you already know about stdio.h. Then the standard library function math.h. It has many math functions, for example, sqrt, C. We'll read about them. We'll floor. Okay, string functions are there in string.h. We'll be using them. ctype.h is present. Character handling functions, timestamp. Many a times you have to make a program in which you have to find how much delay is there in executing a for loop. So what you do, you print the timestamp here, then you run the for loop, and after coming out of the for loop, you again print the timestamp. So this tells you how much time elapsed for the processor to execute this for loop. For example, this was a loop for 100 times and 3 statements. So 300 statements were executed in 0.13 seconds if you got. So these kind of programs require you to have a timestamp. Those are present in time.h functions. Okay. So similar, sorry, time.h header. So these are some common header files which we'll learn about some common methods which we will be using in our programs also. Okay, now coming to a very important topic called derived data types. See, derived, the word itself explains it. The word explains itself. So derived data types are the data types who have been derived or who are built upon the primary data types. What are the primary data types? Int, float, char. So using these data types, when you build some complicated versions of derived data types, they are also called user defined data types because their size is not fixed. For example, the size of int is fixed, long int is fixed, char is fixed. Their size is not fixed. They are defined by the user. Depending upon how much space you need, you can create your own data types. Okay. The two most important examples which we'll be reading here are arrays and strings. Okay. Now let's first start with arrays. There might be someone who is hearing this word for the first time, so I'll just explain for them. Arrays are arrays are basically a matrix of data, or you can also understand it as an ordered list. Okay, whenever we have to make a list of things, we can use arrays. Okay, for example, you must have made list of groceries, not check boxes, and so that you can independently, if you have bought this item first, so you put a tick here. If you, then you're buying this one, then you put a tick here. So it is an ordered list. Maybe you are arranging by priority. Okay, first you have to do this, then this, then this, then this. Okay, and you can access any value anytime by their index number. So that is how arrays facilitate us. Now, why do we use them? This can be understood by a very simple example. For example, assume that you are a maths teacher. Okay, and you have 70 students in your class. Now you have to store the marks of these 70 students roll number wise. Now one way is that you create 70 variables, and then you will spend the rest of your day remembering the variable names and trying forgetting the names, and then you have to look for what variable was there for the roll number 19, what was there for roll number 25. So different memory locations which are independent of each other. Rather than that, if you use array, what it does is it allows you to use one single variable to access all these 70 memory locations. Means You can have 70 memory locations. You can store math marks in those 70 memory locations, but you can access all of them by one single variable, just by their index number. It will become more clear, if when we look for some examples. For example, there is an index number which tells us which block are we referring to. Okay, and that index number always starts from 0. For example, if you are creating an array of 3 blocks, okay, and the name of this array is, sorry, arm. So this is the first index number, which is 0 basically in computer language. This is index number 1 and this is index number 2. Okay, just remember that index numbers always start in arrays from 0. They don't start from 1. So if I have to access this data here, I'll refer to it as arm1. If you print arm1, then this data will be printed. Okay, index number is represented under square brackets. So that is one thing that you need to remember, that index number always starts from 0. And one more thing, all the data in our array should be of the same data type. If you are creating an integer array, okay, then all the numbers should be integer only. Now let me show you something. Yeah, a simple idea of the array indices. This is an array. I hope you can see that its size is 9. It has 9 blocks, but you can see that starts from 0 and ends at 8. So the first index is 0, last is 8. So if the size of an array is n, so the last index will be n minus 1. This is something that you should keep in mind. Okay. Now let us see how we can create arrays. Arrays can be of two types: one-dimensional arrays and two-dimensional arrays. Okay. One-dimensional arrays means they only have one row, and two-dimensional arrays means they have rows as well as columns. Okay. So we'll learn about both of them. Let's first start with 1D arrays. Now, first thing is array declaration. How do we declare an array? See, and a 1D array can be declared in many ways. Okay. You should know those ways, because otherwise, if you see on a new way, then you feel that okay, there is some error there. The simplest way is to tell the compiler what is the size of the array. For example, I'm creating an integer array of size 3. So an array like this will be created. Okay. The compiler, this is the size of the array which I'm telling the compiler that it should be 3 blocks. Of course, this is the 0 index, this is first, and this is second. Another way to do this is I can take an input from the user. Okay. For example, I create int n, then I scanf, enter size of your array and n, and then I create an array int n. So an array of size n is created. N has been specified by the user by giving an input. Okay. Another way is I can initialize the array also here. For example, if I'm creating an array of size 3, so I can write here 7, 8, 6. So the array of size 3 will be created, and the first row will be, see, whenever we create a block now, it represents one row. Remember this, it will be helpful when we are understanding 2D arrays. So 7, 8 and 6 will go in first row. Since it is a one-dimensional array, so it has just one row. Now one more interesting thing is that if you are, this is initialization of the array. If you are initializing the array at the same time when you are declaring it, you can omit the size of the array. Compiler will understand it. For example, I could have also written it like this: int arm. This would also be correct. The compiler will automatically understand that okay, there is only one row and 3 columns, so the size of the array is 3. This is for one-dimensional array. We can do this only if you are doing this initialization along with the declaration. If you're doing them separately, if you're first declaring the array, then you have to specify, because if you're writing it like this, See, it's more of a common sense. If you're doing it like this, int, then you are doing um, see when the compiler comes from this line, it feels a it feels a dilemma that what size of array should I create, and therefore it will give an error. Whenever the computer gets confused, it will give an error. It is not smart enough to have patience that okay, let's see the next line and then I'll see whether I should give an error or not. It will give an error here itself. So if you're doing the initialization declaration separately, then you cannot do like this. But if you're doing it in the same line, then you can directly initialize without the size as well. Okay. Now accessing array elements. I've already told you that the index starts from 0 and goes till n minus 1, and is the length. For example, let us see an example here. I'm creating an array of size 5. Now I'll take input. Now index number starting from 0 less than 5 I plus plus. Basically what this loop does is it runs from I is equal to 0 to 4. Okay, and every time for every index number it asks the user to enter a number and stores it in arm I. So arm 0 में एक value stored होगी, then arm 1, then arm 2, then arm 3, then arm 4. So this loop executes 5 times and 5 values will be entered by the user and stored in the array. Now we have to print the array. So maybe we want to the user to enter a location, enter an index number which he wants to print, index location. Okay, so scanf, you take an input in n and then we just print it. What do we print? Arm n. So basically the user enters an index number which we print. Of course, for safety reasons you can check here that n should be less than equal to 4. He cannot earn greater than equal to 0. So you can do those checks. But what I meant to say is this is the way we can access the value of an array, and this is the way we can take inputs using scanf statement. It's quite easy. You just have to visualize it as a list of numbers. I hope it's clear till here. 1D arrays. Then I'll show it to you in the compiler. I'll just give a little introduction of 2D arrays and then we'll do some programs. So I hope 1D arrays is clear to everyone. Now 2D arrays is nothing but when we have rows and columns. Okay. Then we have both rows and columns, it becomes a 2D array. So for example, a very simple syntax can be float imli 2 3. Now always remember, first we specify the rows and then we specify the columns. So basically this will create a array imli which has 2 rows and 3 columns, something like this. Okay. Now as you already know, the index numbers start from 0. So row 0, row 1, column 0, column 1, column 2. Okay. So though the length is 2 comma 3, but the variation of the index is 0 to 1 and 0 to 2. This is something that you need to keep in mind. So for example, if we have to access this value here, how will we use it? Access it imli 1 comma 1, first row, first column. So this is the name of the block. So every block can be accessed by this same variable name imli. Okay. Now I can initialize this variable also at the same time. For example, float imli 2 3 is equal to, I'm writing it in a fresh line. Now see, I have already told you one block represents one row. So if I'm writing the first row 1 comma 2.2 comma 3.7. Then the second row will be 7, 8.6, anything, 4.9. So when you write like this, the compiler knows that okay, this is one row, the first row, first column, second column, third column, and this is the second row. So row wise you can input the data. Okay, it's not necessary, but this is more convenient even for the programmer to understand that okay, this is the first row of data, this is the second row of data. You can even write the data in one line. That's not an issue. The compiler will know that. Now one thing that you need to, now if you have to access the, it will become more clear. We'll do a simple program, don't worry guys. For example, if you have to access the variable here, value here, so it becomes imli11. Imli is the name of the array. Okay, I hope it's clear. Just one thing guys, you have to remember that you remember in one dimensional array, while initializing, if you initialize and declare in the same line, then you can omit the size of the array. In 2D array also you can omit, but you can only omit the first one. You cannot omit the second dimension. You have to specify the second dimension. What I'm meaning to say here is, see, I could have written this statement like this also. It would be perfectly correct. Okay, but I cannot write it like this. This will be wrong. The second dimension has to be there. Okay, you can omit the first dimension, but you cannot omit the second dimension. So the safest thing to do while coding is to always give the dimension as long as you know it. Okay, this was about 2D arrays. So for example, okay, let's do a question guys. In a few questions it will be clear, don't worry. Write a program to create an array of 20 numbers and print their sum and average. Of course, you have to create an array of size 20 numbers. You have to take the inputs from the user, because the best programs are the user defined programs, and then you have to print their sum and average. In fact, better than 20 numbers, make it n numbers. Ask the user what size of array he wants, create that array, and then get the values from him, and then print their sum and average. Let's first do it with 20, and then we can of course change it. So when maybe we are creating an array named A whose size is 20. Now for int I starts from 0, I less than 20. I hope you are clear why we are taking less than 20, because it will go from the indices will go from 0 to 19. Okay, then what do? We write a printf statement for the user, enter a number, then we take input, and at the same time when we are taking input, we can also add it in a sum variable. Sum is equal to sum plus, because the user has given the first input, so we can just add it so that we don't have to use another loop. You can also do this, that you first get all the values in your array, then you run a different loop, and then you add the numbers, but it's better to do it in the same loop. Of course you have to declare a sum here. Okay, sum equals to 0. Now once you have done that, you can just calculate the average in a float variable. Make sure you use a float variable, sum divided by 20.0. Okay, then you print the sum and average. Now if you have to do the same program, instead of 20 you have to use n. First understand it with 20. Just take 10 seconds if anyone of you needs any time. Okay, now if I have to do the same thing with n, so what I'll do here is, instead of 20 here I will write n, instead of 20 here I'll write n, and first I'll take an input from the user. Okay, scanf %d and n. So first he'll tell me what is the size of the array that he wants. Then I'll create an array of that size. and then I'll run a loop till n minus 1 0 to n minus 1, and then I'll take n minus n values from him, and then of course I'll do, then everything else is the same. So just changing that changes my structure of the brings a lot of flexibility in your programming. Okay, I hope it is clear. If anyone has a doubt, please ask. AI is the value of that location in the array. Yes. See, I is the index number, and AI refers to that. See, basically, an array is a collection of variables. Okay, and if you imagine it this way, it will be easier for you to understand. For example, if I'm creating an array arm whose size is 3, so basically these are 3 different variables. Okay, and they have been stored in successive memory locations, and this entire array is referred to as arm. So if I have to access the first variable, I use the index number arm0. For the second one, I use arm1. For the third one, I use arm. Let's understand it by a question. um Anything, for example, if I ask you to create, let's do it a question, do a question, and let's do you have to create a 3 into 3 array. Okay, you have to take inputs from the user, and then you have to print the sum of the shaded regions. Okay, you have to create a 3 into 3 array. You have to take inputs from the user, and then you have to print the sum of the shaded blocks. Just take an attempt, and then we'll do it. Okay, let's try this together. See, this is an integer array, so let's give it some name. For example, display. The size is 3 and 3 rows and 3 columns. So we have declared an integer array, 2-dimensional integer array, size 3 rows, 3 columns. Okay. Now we'll take inputs from the user. For that we use for loop. For I is equal to 0, I less than 3, I plus plus. For j equals 0, j less than 3, j plus plus. Printf, enter a number, anything, scanf. See, don't get confused. When I and j are basically changing the index numbers, so the current value of I and j are referring to a certain set of index numbers which refer to a certain variable of the array. So that variable is an integer data type, right? So we can just write it like this: this I comma j. Is this clear to everyone? This is the AND sign, display array ith and jth index value. That is there, that at the address of that memory location, the value entered by the user will be stored. And that address is actually an integer type, therefore format specifier is %d. Okay, so I'm hoping that everyone is clear there. Now what we have to do is we have to find the sum of the shaded regions. So what are the shaded regions? Let's find out. 0 1 2 0 1 2. So basically this region is 0 0, this region is 1 1, and this region is 2 2. So when I equals to j, it is either this block or this block or this block. So what you can do is, once you can take all the values from the user, and then you can run fresh loops of I and j, and then you can check and store the sum. But if the loop is already running and the user has entered the value, why not use the same loop instead of running a different loop? So here only I'll write, if I double equals to j, sum equals to sum plus this I comma ij. In fact, instead of this, you could have also written this I, because already I equals to j. So even if you write I, it's the same thing. Okay. So we just add that if statement there, and we end the loop, and we then end the other loop also. So what will happen whenever I equals to j, it will be stored in a sum variable, and then you can print that sum. And if you want the average, then you can find average is equal to sum by 3.0. So I hope it's all clear to you. Average must be float, of course. Did everyone understand this question of two-dimensional array? Because see, when we understand these two, then only we'll move to the next topic, which is searching and sorting of arrays. So for that, we need a proper understanding of 1D arrays. If I had shaded all these blocks, then what would be your question? What would be your condition? See, these are 0, 0. Actually, it is I is less than equal to j. That I is less than equal to j. See, for example, the second block. So if I, as long as I is less than equal to j, which is I is greater than equal to j. Yes, you can use this condition, I greater than equal to j, right? So, for example, if I is equal to 2, so j can be 0, 1, 2. When I equal to 1, then j can be 0 and 1. So, j is less than equal to I, or I is greater than equal to j. Both, if you put these conditions, then you will only get these shaded blocks. Okay. So the question can be changed like this. I hope it's clear. Okay, guys, I hope it's clear till here. Now we'll understand a new topic, which is searching and sorting of 1D arrays. See, searching means when you have to look for something, because when we have made a matrix, okay, when you stored a lot of data, sometimes we need to search for some data, whether it is present in that list or not. For example, if you have made a list of all the students who have passed the exams, right? So in that case, yeah, what I was saying, yeah, if you have made a list, for example, of all the students who have passed in your school. So now a student comes, he wants to know whether he has passed or not. So there should be a facility where he can search his name in that list. Okay. So that is what, of course, searching is very clear. And sorting, what is sorting? Sorting is basically when you're manipulating that data. For example, if you have a list and you want to change that data and rearrange it in ascending order or descending order. Mostly we need ascending and descending orders. Okay. So for example, if you are buying the same product, so there's a website which will tell you what is the cost at which it is available on Amazon, Flipkart, Snapdeal, and other e-commerce websites. So they will tell you in ascending order. So there's some sorting happening there. They are taking the data from different sources, but when you're before displaying it to you, they are sorting it in ascending order, right? So we will learn some. There are many different techniques to do these, okay? But we'll learn some simple techniques of searching. Basically, one simple technique for searching and sorting of one-dimensional arrays. For example, we can understand them with a program. Only write a program to create a user-defined array, then take values, then ask for a value to search, and search that value, and if it is found, print its index number, or print its position basically. And if it's not found, then say that it was not found. Print its position. Instead of user defined arrays, for simplicity, for now you can create an array of size 20. Okay, just create an array, take values, then ask for a searching element, and then search for that element. Let's just try how we can take an attempt, whether you can take an attempt at this. Okay, let's try this one. For example, int Rohan 20. So I've created an array in Rohan whose size is 20. For I is equal to 0, I less than 20, I plus plus. I'm not writing the printf statement, but of course you have to write it. And okay, this will take the inputs. Since there is only one statement, so there is no need of curly brackets. Still, if you love them, you can put. Now I'll ask for a searching number. Enter what to search. Then I'll take input. Now n is the value which I have to search in my array. Okay. So again I have to go through all the elements of the array. So I'll use a loop. Now if Rohan I is double equal to n. So see, I is basically changing the index numbers from 0 to 19. At any and at every position, I'll see if the value stored is equal to n, which is the what the value the user wants. Now, if I have found this value, what I do is I just print it. For example, I can print it here itself. Print number found at %d, which is the position at which we have found the number I plus 1, because I is the index number. So if you have found at index number 0, this is basically the first position. So 0 plus 1. This is printed, and after printing this, we don't need this loop to continue because we have found our number. So we can just break out of the loop just to save our execution time. Even if you don't break, of course it will come out, you will get the value, but you can, if you break, then it will be better. Now I can end the for loop here. Now assume that we didn't find our variable. Assume that at no value of Rohan, no value was equal to n. So what will happen? This loop of I, it will go on continuing because there will be no break statement which will be executed anywhere. So what will be the last value of I when the control comes out of the loop? Tell me the last value of I. If this loop never the value is the number is not found anywhere, the loop executes till its last value, and when it comes out, what will be the value of I? 20. I'll just explain to you. See what happens every time. First this update statement is executed, then this is checked, and if this is true, then this block is executed, right? Now for when I equals to 19, this is true, this entire block is executed. Then the again control comes back to here. So I is updated to 20. Then it goes to check here. This condition is false. So this block is terminated. But the last value of I is 20, not 19. Right? So if the loop has executed completely, that is, if I is double equals to 20, this means that the value was not found. So we can print that not found. I hope it is clear. Okay, now let's try a sorting question. See, these are the practical use. For example, sorting question can we write a program to create an array of 100 elements and arrange it in ascending order. So no matter what elements are entered, the program automatically rearranges the array in ascending order. The same array is rearranged in ascending order. So this is a very useful application of arrays. This is, and the technique which we will use right now is called bubble sort. See the searching that we did here, na? This is called linear search. Okay, because this is very straightforward. We go to every place and we see, okay, is this equal to n? No. Then we go to the next place. So it's very straightforward. It's linear search, and yeah. This sorting question you can't attempt it on your own. So let's do this. Okay. Periodic table and then looking for something there. Yes, you can do it, but for a periodic table, you have to take care that you have to leave the spaces vacant. For example, the places we have which are vacant, because the actual periodic table is not a rectangular one. There are places where we don't have anything. So you have to leave them vacant, and of course you can look for it. In fact, most of the data which is stored on servers is stored in huge matrices, because it's very easy to matrices were invented when the data became very large, and to manipulate that data we use matrices. If any of you have used work with MySQL, so you would have seen how we use arrays there also, and we can create the whole database of some companies are stored using MySQL, so arrays are used there. And one of the other benefits is, for example, if you're working in a company, now your data is in different departments, salary department, fine department. Now you change your address, so the data is connected with a central array, and if your address is updated there, your address will be updated everywhere, or if your contact number is updated there, it will be updated everywhere. So you don't need to, have update it at every instance. So there are many benefits of using arrays. Now let's try this question. For simplicity, let's convert it to 10 only for right now. 10 elements, and we have to arrange them in ascending because it will be easier to understand for you. Acha, before this, I haven't taught you about swapping the variable. No? Okay, we need something for this question, so let's understand that first. For example, there is a you can try this question. It's an interesting, easy one. There's a variable a in which you have to take input from the user. There's a variable b in which you have to take an input from the user. Then you have to swap these values and then print them. Matlab, b's value should go in a and a's value should go in b. Now it's just like, you have two glasses of water, and you need this liquid in here and this liquid here. So what do you use? You use a third variable. You just empty this glass here, then you pour this one here, and then you pour this here. That's the same concept which we'll do. We'll use a variable c in which we'll store a, then we'll use a equals to b, and then b equals to c. So the value of a and b got interchanged. I hope it is clear to everyone. It's quite simple. As a interesting homework, you can try doing this same job without using a third variable. See here, it was very easy because you used a third variable c. Now I'm saying you can't use a third variable. You only have to use a and b, and you have to interchange their values. Just try it. Just try it on you. Now this concept will be used in this question. Okay. So first we create an array. The first thing that we do is we create an array, of course. So array 10. Now understand this bubble sorting very carefully, because sometimes people get confused here. Okay, it's quite easy, but the looping is a bit complicated. First I'll write it, and then I'll explain to you how it is getting executed. Okay, I have to take the input now. So it is I less than 10 I plus plus scanf. Okay, input is done. Now we have to sort the values. See, once you have taken the inputs, it is something like this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9. Now we have to arrange these values in ascending order. Okay. Now see, what is the technique that we will be following? Let me first explain it to you. What we do, we take this value, first value. Okay. Then in every, see, we'll be executing the program for 8 times, and every time what we'll do is we'll make sure that the largest number reaches the bottom. Okay. So what we'll do is, for example, we take this number. For example, there is 3 here and 4 here and 1 here. So this is 13, for example. So we compare this 13 with 4. Since 13 is greater than 4, we'll interchange them. We'll put 13 here and we'll put 4 here. So 4 will come here and 13 will come here. Then we'll come to the second index. Then we'll compare it with the third index. For example, if 17 is there, so 17 is already greater than 13, so we won't do any swapping. Then assume that 4 is there, 17 and 4. So 17 is greater than 4, so we'll swap the values. 4 will go up and 17 will come down. So basically what is happening, whichever greater number is being encountered in the process, it is coming down. So ultimately, for example, if 25 was somewhere, so ultimately 25 will come here. Then the same thing is executed next time and the second greatest number comes here. So in every round, one number is settled, and as we progress, the entire array is sorted. I know it is confusing. Let us understand this by program. Um, 10 examples, it might be confusing. Okay, chalo, let's try. See, guys, just bear with me. I'll explain it to you. This is just swapping of the variable. This if loop is ending here, one for loop ends there, and one for loop ends after it. Now, guys, I want you to draw a matrix in your notebooks because this screen is going to scroll every time. So just draw a matrix like this. It will help us in understanding this. Okay. Let us store some values here. For example, 4, 3, 11, 9, 73, 8, 7, 5. Just assume that these are the values which have been given by the user. Okay. Now, can you see that 73 is the largest value? So our program will first bring 73 to the bottom. Let's see how. Let's not first think why this is 8 here. I'll explain it. You'll understand it when you understand the execution. Let's just first understand for I starts with 0. So the first value of I is 0, right? And the first value of j is 0. Now j will vary from 0 till 8. Okay. Now if array j, so basically 0 and this is 0 plus 1, 1. So if 0 is greater than 1 position, so 4 is greater than 3, this is true. So this part of the program, as you can know, this is just swapping these two positions. So what will happen? 4 will become 3 and this 4 will come here, right? I hope it is clear. Does anyone have a doubt till here? Yeah. Sorry, the screen got closed. Yeah. Does anyone have a doubt how this 4 and 3 have got interchanged? Is it clear to everyone? Guys, just tell me it's clear so that I can last step once more. Okay. See, Kritika, first just understand that the first value of I is 0, right? And the first value of j is 0. So j is starting from 0 and j will go from 0 till 8. I hope this one's just know that this is happening. I'll explain why we have written it like that. Now we are just checking if the 0th position, first value j is 0. So if r0 is greater than r1. Is r0 greater than r1? See the original values here were. Original value was 4 and 3. So R0 is 4 and R1 is 3. So 4 is greater than 3, rest. Then they will be interchanged. So when you interchange them, basically 3 will come here and 4 will come there. Is this clear to everyone? Now let's go in the next loop of J. See, J loop, J is getting executed. So after this swapping, what will happen? J ka value will become 1, right? Now R1 is greater than R2. Let's check. Is R1, what is R1? 4. This is R1. Okay, let's first write the index values because someone can get confused there. Let me write the index value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So R1 is 4 and R2 is 11. Is R1 greater than R2? No. So no swapping will be done. This swapping part will not happen. The numbers 4 and 11 will be remaining as they are. Now J becomes new value of J is, see the J loop is executing. So now J equals to 2. So now is R2 greater than R3? R2 is 11 and R3 is 9. Yes. So they will be interchanged. So 9 will come here and 11 will come here. Is it clear? Now it should be clear to you that this thing will again happen. See, for J equals to 3. So is R3 greater than R4? 11 greater than 73? No. So they will remain as it is. Then J equals to 4. R4 greater than R5? Yes. So they will be interchanged. So 8 will come here and 73 will come here. Now see what is happening after that. Is R5 greater than R6? Yes. So they'll again get interchanged. 7 will come here, 73 come here. Is R6 greater than R7? Yes. So they'll again get interchanged. 5, 73. Is R7 greater than R8? Yes. So they'll again get interchanged. It was 17 here, no? 17 and 73. Now the last value of J is 8. Is R8 greater than R9? See, automatically R9 is coming here because J plus 1 is being used. And I hope this makes it clear why J is going only till 8, not 9. Because when you go to 8, you are automatically taking J plus 1, 9 into consideration. So if I run the loop till J equals to 9, then it will look for J plus 1, that is 10th position. 10th position is not in our array. That is why we run it till 8 only. Okay. Now is R8 greater than R9? Yes. So 73 will come here and 25 will go up. So now just look at your array. The biggest number has come at the bottom. Is it? Can you see it? Our biggest number was 73. It has come at, but the other numbers are not yet organized. But the biggest number has come at the bottom. The J loop is over. Is it clear to everyone? I'll recommend you write this array in your notebook, and as I do it here, also do it in your notebook. Then it will become clear. Now see, the J loop is over. The first J loop is at least over. Now what we'll do is we'll go to the next I loop. Now what is the value of I now? The value of I is equal to 1, right? Yes. Now again J will run from 0 to 8. Now what do you think it will happen? Again the same thing will happen, but now 73 is out of the picture. So again at every step, now I'm doing it, now I'm showing it how it is happening here. See, again 3 and 4 will be compared. Is R0 greater than R1? No, so nothing will happen. Is R1 greater than R2? No, nothing will happen. Is R2 greater than R3? No, nothing will happen. Is R3 greater than R4? Yes. So 11 and 8 will get interchanged. Look carefully, guys. Is R4 greater than R5? Yes. So 7 and 11 will get interchanged. Is R5 greater than R6? Yes. So 5 and 11 will get interchanged. Is R6 greater than R7? No. So nothing will happen. Is R7 greater than R8? No. Is R8 greater than R9? No. So do you see the second largest number has reached here? It has not reached here, it was already here, but one number has reached. Now it must be clear to you that the number of times we run the loop of I, every time one number will reach its destination. Now how many numbers we have? We have total of 10 numbers. But do we need to run the loop for every number to reach their destination? No. We only want them to run to the 9 numbers to reach their destination, because if 9 numbers reach their destination, the 10th number is already at its destination. So that is why this loop of I we are running from 0 to 8. See, 0 to 8 if you run, it will only run for 9 times. Okay. So if you run it for 9, you could have also run it from 1 to 9. That doesn't matter. What I want to tell you that you could also run it from 1 to 10, but we just saved one loop by running it from 1 to 9, because we know that if we have sorted 9 elements, then the 10th element is automatically sorted. I hope now everyone has understood why I loop was going only till 8 and not 10. Now here, if this was a user defined array, then it will be going till n minus 2. See, n is the size of the array, which is 10, and here also j will go till n minus 2. So if it was a user defined array, you would write n minus 2. Since it is a 10 size array, so I have used 8 directly. Is this program clear to everyone? Guys, draw an array in your notebook and understand clearly how it is working. So in the end, what will happen? All the numbers will be arranged in ascending order. Guys, anyone of you who have a bit of doubt, I know this will have doubt and it will only get cleared by one way. Take a screenshot or write the program once. Okay, and after the class, make an array of your own. See, here I have made an array now. Make an array in your notebook, put values there, put random values, and then execute every loop and see what is happening, how the numbers are getting interchanged. Then only you will understand it completely. I can explain again, but I'll do the same thing, and you won't get it unless you make an array of your own. So just make an array and see how they are getting interchanged. Write the program, copy the program, take a screenshot, whatever you do. But the best way is to make a random array and execute the program and see how the compiler is working. Okay. Okay, guys. Then we are calling it a day. Just make a random array. Try to understand it. Okay.